Hello everyone. Today I'm going to teach you how to do absolute values. And by the end of this class, you should know how to do every type of the question that will appear in the exam. So firstly, absolute value. Have you seen this sign before? Well, this sign just means absolute value. And what does it mean? It just means that it turns every real number into a positive real number. For example, the absolute value of 5 still equals to 5. However, absolute value of negative 5 is equal to 5. This means if we have absolute value of x is equal to 5, x can be equal to 5 or negative 5. This is going to be very useful for the second way, but we are going to deal with the first way first. So the first way to solve most of the absolute value questions is by timing bracket square on both sides. So firstly, we have an identity that the absolute value of a bracket square is equal to a square. Well, actually congruent. Congruent is just mean that it always equal to. So by proving this, we have two cases. First case, when a is positive. When a is positive, we can straightly see that the absolute value of a is equal to a. So we do bracket square on both sides. We proved this already. Second case, when a is negative. When a is negative, we can see that the absolute value of a is equal to negative a. And we bracket both sides, we get the same thing. So we have proved that this exists. Okay, so this means that now we have an exercise. Let's just look at it. So firstly, the absolute value of 2x minus 1 is equal to 3. By using this formula, we can see that if we bracket square both sides, it still works. And the bracket square of the absolute value is equal to the bracket square of 2x minus 1. Which means 2x minus 1 bracket square is equal to 3 squared. And this is a simple quadratic equation, and we can solve it easily by factorizing it. And we will get x is equal to 2 or negative 1. However, this way can only be used when x is to the power of 1. Because if we have an x that has x cubed or x squared, and when we do bracket square on both sides, it becomes x to the power of 6 or x to the power of 4, which we can't use any way to solve it, or it's very hard to solve. This means we need another easy way. So do we have another easy way? Of course we have. This is our second way. And for the second way, we have already known that the absolute value of x is equal to x for all x greater or equal to 0, and for absolute value of x is equal to negative x for all x is smaller or equal to 0. Well, you can just substitute when x equals to 5 or x equals to negative 5, and you will see that this is all true. Okay, so now these part are just proving that. Well, let's just start the exercise. So we have the same question again, that the absolute value of 2x minus 1 is equal to 3. Now let's still consider two cases. Firstly, when x is greater or equal to half. This means that 2x minus 1 will always greater or equal to 0, which by using that, we can see that 2x minus 1 to the absolute value is equal to 2x minus 1. Now we can solve it. Now we can substitute by using 2x minus 1. So which means 2x minus 1 is equal to 3 and x is equal to 2. So first case is solved. Now let's consider x is smaller than a half, which means 2x minus 1 is smaller than 0. And in this case, by using this formula, we can see that the absolute value of 2x minus 1 is equal to negative 2x plus 1, which means negative 2x plus 1 is equal to 3, negative 2x equals to 2, and x is equal to negative 1. So we get the answer of x equals to 2 and negative 1, which is same as we have done here. Well, so this means both ways can work and both ways are correct. Now let's do another exercise. Let's read this problem. Well, but firstly, if we have two ways now. One is to bracket square. The other is determine the range. So let's consider the first way, that we bracket square on both sides. We can see that it's not very convenient because there is a term of 2ab, that is 2 times the absolute value of both. And we need to complete this, we need to square both sides again, which is we will get a power of 4 of x, and we can't solve it. This means that the first way can't work. So let's consider the second way. Let's consider 3 cases this time. Firstly, when x is greater or equal to a half. At this case, we can see that both of them are greater than 0, which means this formula again, which is very important. We can see that this equation can change into this equation, and you can solve it quite easily, which is x is equal to 5 over 4. The second case is x is smaller than a half but greater than negative half. In this case, you can get that 2x minus 1 is smaller than 0 and 2x plus 1 is greater than 0. And from here, you can see that 2x minus 1 to the absolute value will equals to negative of itself. But for 2x plus 1, it doesn't change. Now we will get this equation. However, this equation doesn't mean anything. We will get 2 equals to 5, which is obviously not correct. And the last case, for x is smaller than negative a half, we can get that both situations are smaller than 0, which means both absolute value will equals to negative of those two. And when we add these two together, we can get that negative 4x is equal to 5, and x is equal to negative 5 over 4, which solves the problem. Okay, so this is the end of the equation part. Now let's look at the graph of y equals to absolute value of x. Well, we have already know that the absolute value of x is equal to x, or sometimes it will equals to negative x. So let's draw y equals x and y equals negative x, which is these two lines. However, for absolute value of x, it is always greater or equal to 0, which means for the value of y that is smaller than 0 does not exist, which means this part does not exist. Now, so we have the graph like that. And this is the graph of y equals to absolute value of x. However, the questions like that is quite easy to solve because you can just simply by substitute all the values in and plot the graph, and you will get the graph. So the graph part is actually the easiest part. Now let's look at the inequalities. Inequalities are not that difficult if you understand the equation part, because it is quite similar to the equations. Okay, let's consider this question again. The absolute value of 2x minus 1 is greater than 3. Let's find the domain of x. Well, we do the same thing. We split the question into two cases. For x is greater than half, the absolute value doesn't change, which means 2x minus 1 still equals to 2x minus 1. And for x smaller than half, the absolute value of 2x minus 1 is equal to negative bracket 2x minus 1. And from here, we can do the two cases again, and we will get x greater than 2 or x smaller than negative 1. However, this is very important, that is to check your solutions, because how do you get x is greater than 2? You have assumed that x is greater than a half. If x is like, for example, x is greater than 1, you assume that, and your answer is x is smaller than negative 2. Your answer, then this is not correct. So an important thing is to check, does your answer fit in the range that you assumed here? However, we can see that x is greater than 2, it does fit, and for x is smaller than negative 1, it also fits. So now we can deduce that the answer of this question is x greater than 2 or x smaller than negative 1. So for all the other questions in inequalities, you can just solve them by just deal with it like it's an equation, and you just solve an equation, but in the end you add the greater or smaller signs at the end. So this is the whole session of absolute value, and I hope you understand of all of those. If you have any questions, you can comment below. Thank you.